Professor Bumbleweed here. Yellowstone sits on a gigantic volcanic system, and people love asking if it explodes. In a few minutes, this explains what the supervolcano is, what an eruption looks like, and why ash causes the real chaos. Buckle up. No yelling, no doom soundtrack, just clean science with a little side-eye. This video keeps it fun and useful. What Yellowstone is, how scientists watch it, and what ash and climate effects look like. Time for a closer look. Yellowstone is not a cone-shaped volcano. It is a caldera, a huge sunken area formed after massive past eruptions. Geysers and hot springs sit above hot rock and circulating groundwater. The supervolcano label refers to eruption size, not attitude. Yellowstone produces earthquakes and ground movement all the time. That sounds scary until you remember. A living planet moves. Scientists monitor with seismometers, ground deformation tools, and gas measurements. Most changes reflect fluids and faults, so evidence matters more than dramatic headlines. Before any huge eruption, the ground gives hints. More earthquakes, changing steam vents, and measurable uplift or subsidence. None of this equals doom, but it signals pressure and fluids moving underground. Scientists look for patterns that grow stronger and more persistent over time. Explodes is sloppy wording, but the visuals are dramatic. Gas-rich magma fragments into ash, blasting a column skyward. Close to the vent, pyroclastic flows behave like a fast, hot avalanche. Farther away, gravity and wind turn the air into an ash delivery service. Ash is pulverized rock, and wind spreads it far from the volcano. It reduces visibility, irritates lungs, and grinds up machinery. Heavy ash accumulation adds weight to roofs and clogs drains. The annoying gray dust causes wide disruption long after the dramatic eruption cloud looks done. Ash messes with systems people forget about. Water treatment, power equipment, and engines. It clogs filters, contaminates supplies, and turns moving parts into grinders. In the sky, ash is a serious hazard for aircraft, so flights reroute or stop when ash clouds sit in the way. Eruptions inject more than ash. Sulfur dioxide in the upper atmosphere converts to reflective sulfate aerosols. That reduces incoming sunlight and can cool the surface temporarily. How strong? It depends on eruption size and altitude plus weather patterns. Sadly, the planet ignores simple timelines. After the dramatic plume, the annoying part continues. Ash cleanup and disrupted systems. Hazy sunlight and shorter growing seasons stress agriculture in some places, while transport and power deal with abrasive dust. The result is shortages and price spikes. Not the end of Earth, just a hard reset. Ash response is mostly unglamorous basics. Protect breathing and eyes, keep ash out of ventilation, and clean without kicking dust into the air. Communities prioritize safe water, power, and medical needs. The big lesson: distance from the volcano does not equal safety from ash. Recovery is slow, not cinematic. Ash removal takes time, infrastructure repairs take time, and ecosystems gradually adjust. Plants can regrow through thin deposits, and landscapes change for years. Yellowstone already shows resilience after fires and harsh winters, but a huge ash event strains everything at once. Everything you just watched boils down to this. Yellowstone equals caldera plus monitoring, not instant doom. A large eruption brings violent local hazards, then widespread ash that damages machines, water, and travel, plus possible short-term climate effects. The frozen television image ties the hazards together. Like the video if the science to sarcasm ratio feels right, because that feedback shapes the next topic. Then leave comment suggestions for other what happens if ideas. Silence needs direction, and dramatic hand motions need purpose. Thanks for watching, and see you next time!